Hey everyone, welcome back to my channel. So in today's video, I will try to go dive with you with the support vector machine. I will try to make it very simple, and almost all the videos in YouTube, they just give you the equations and sometimes it's not even clear. They just explain it as a theory. In this lecture, or this lesson or video, I will try to make it very simple, and I'm quite sure that you will understand every step in this support vector machine. And of course, because I provide you with a small example, let's see, real time, not real example, but it's, as you can see, it's with everything and it's calculated, and I'm quite sure that you will understand everything here. So let's start with what is the support vector machine. By the way, this preparing this document, it took a lot of time for me from me. So if you like this, please subscribe and like the video, and also if you have any question, just drop it down in the comment below. So what is the support vector machine? So yeah, with the support vector machine, I will try to use a gradient descent, and this example also will be. If you understand everything here, you will understand the, let's say, the deep learning concept, I would say. So what is the support vector machine? Support vector machine, in the beginning, it's supervised learning algorithm, and it's used for classification and also used for the regression. And the idea or the goal behind this is to find the optimal hyperplane that maximizes the separates different classes in a data set. So let's assume this in the previous video we have seen how to how the linear regression is working, and of course I give you an example. So the basic of the goal of the linear regression is just to split the data set into not splitting the data, sorry, it's drawing the line that fit all the data. And it's the same here. We need to draw a line, but the line is the idea is to split the data set. I mean, split to these classes. And if you see here, if I split this data, the line, if I draw a line, so by the way, we only need one line that generalized for the whole data set. So assume that I have this line here. And for the next time I have created this line here. For the third time, maybe I choose this line here. So what do you think, which one is the best? I will see none of these are okay. So why? So if you see, we need a hyperplane, like for instance, starting from here and splitting the data. This is, I mean, all these lines are splitting the data, right? But the problem is here that the distance between these and hyperplane is less, and the distance from this point are too much. So we need to make it, let's say, optimal hyperplane. So this is the hyperplane, and the goal behind this, or the difference between linear regression and this here, is we need to maximize the support, the margin. So what is the margin? As you can see, if I draw a line here, and any point from this class, let's say, I will try to draw a line parallel to this and cross this, for instance, the close point, this point, for instance, and the same for the other class, and the idea is to maximize this distance here between these two margins, margins, plus d and plus minus t. And now, if I have a point in the testing data set, it will go through. It will be here. I will classify it as as a circle. If it's not, if it's here, I will classify it as as a a rectangle or square. And if you go here, and this won't be able to classify, let's say, splitting the data set into two different classes. So let me just go back and go through the example. So I will try to, where's the data set? Okay, let me just copy this data, because it's might be just for simplicity. Okay, so assume that I will apply for the classification for spam detection. Assume that you have receiving some emails, right? And sometimes the Yahoo or Gmail, they will move some emails to the spam folder. Why it is moving this? They are using the classifier. I don't know which one. Maybe support for commercial, any other class, any classifier. But let's say this is the idea. So this is I have one email 1, 2, 3, 4, and I have free word frequency. For example, if you have a free, how many frequency of word occur in this email, and how many when word occur in this email. So, for example, 3 and 2, it will be classified as spam, and it will be moved to the spam folder. So let's start understanding the support for automation. As I said in the beginning, we have to try to create the hyperplane, which is similar, exactly the same as support vector machine. Sorry, the linear regression, and where the W's are the weight, or let's say the coefficient, and X1 and X2 are the features. So here just simplicity. I have used 2 features, 1, 2, and for you could use many features as you want. And this one here is a bias, and in the linear regression is called y-intercept. And for the classification, as you can see, y +1 if it's spam and -1 if it's not spam. +1 and -1. So let's say, I mean, for this it's working as exactly the same as the linear regression. We will try to initialize the weight and b, and try to calculate, let's say, the cost or the loss, and we will try to update these parameters until we get the best, let's say, fit, or let's say the best accuracy. Now let me just maybe uh, see something about this gradient descent. The gradient descent is already described in the previous videos, but there are two steps for the not 2 steps, two algorithms, let's say, or approach to updating the gradient descent is stochastic gradient descent, which is update the weight and be after each training example. So with each example, for instance, after this one here, for the example, I will up I will update the weight, and the new weight will be used for this one here. And after this, I will update the weight, and the new weight will be used for this, and etc. This is called stochastic. And the batch gradient descent, it's updating the weight after, let's say, processing all training examples, or maybe a subset of the examples if you have a big data set. For this simplicity, I will try to use stochastic. It's gradient. It's hard to pronounce, but yeah. So as you can see, this is our loss function, and this term here is try to minimize the error, and this try to maximize the margin. As we see here, is trying to maximize the margin. So for instance, in the beginning, this is the margin, and the second one is this one. It's not that, let's say, optimal. I will try to make it bigger until we're getting this, let's say, the optimal one. Let me just go here, and you can see the W are the weights. So you can already see this, and regularization parameter. This is the regularization parameter, so I will have it as 1. It's also already described in the regularization L1 and L2. So please have a look. And the Y is the class label. Let's say, for instance, in the beginning, I will assume the weight and B are zeros, and the learning, let's see, rate are 0.01. For this, I will use this example here, calculating Y hat. So for the example 1, let me just zoom out. For the example 1, I will try to calculate B hat, Y hat. It's W multiply w times x1 plus b. So it's not x1, it's x indeed. So it will be 0, the y 0 multiplied by the first the xy for instance here, plus 0 multiply times 2 plus the beta is 0, it will be 0. Now there are several steps for calculating for example for the first one. I calculating the prediction, then calculating the loss, and calculating compute the gradient, and also update the parameters. So now I will calculate the loss. So here is 0. I will apply this formula here, taking the maximum of 0 and 1 minus y and y hat. Y in my case is 1 and y hat is 0. So it will be 0, 1 minus 0. Let's see. The maximum of this, it will be 1. Calculating the gradient. And the gradient, it's like this. Take with respect to W1, I will try to use this if y is 1. I mean, the loss is 1. Or just use W as it is. Otherwise, let's see if it's 0. And with respect to B, it will be minus the regularization term C multiplied by the class label if it's 0, if it's greater than 0 or 1. So in my case here, as you can see, the loss function as is 1. So I will use this formula here for the W, and this is for B. So I will see the W minus the W in my case is 0, 0 minus C it's 1, Y is 1, and the X is 3 and 2. So this minus this, it will be minus 2 and minus 3. And for the B, I will use also this because the loss function is 1. It will be minus C multiplied by 1. Multiplied by 1, yeah. It will be minus 1. Now we need to update the parameters. The update parameters, it's the same as the linear regression. The new one is equal minus 1. The old one minus the learning rate and times this term here we have added here. So it will be the sum, I mean the weight, minus learning rate times the weight, let's say the gradient, this one here. It will be this one, right? So this is the new weight, W1 and W2. And the B, it will be 0.01. And I will do it for the next example. For the next example, it's 1 and 5, and the class label is minus 1. So what should I use for the weight? The weight should be used, I will use the new one here. That's why it's called stochastic gradient descent. It's like updating the weight after each example. This is the concept. And for this example 2, I will try to use the new weights, which is this, and this is the B, and do the same stuff here and updating the weight. And for this, I will have these two values here, the weight, and 0 for the B. And I will apply, I will do this for each example until finishing the dataset. Let's see. And this could be, for instance, after all processing steps, I will have the weight like this, for instance. Now this should be repeated several times until coverage, let's say, until getting the best result, or let's say minimum loss and maximize the margin. And this will be repeated several times. Let's say after 100 epoch, it will be this 0.5 and minus 0.2. Disregarding the parameters. So for that, I also have a Python code for this, or is support for machine. Let's see. So you can see here I created a class, And the class parameters are learning rate, C, and number of ebooks, and also the weight and the bias. Let's see term, but now it's none in the beginning, and for the for the fit, or let's say for the training, it's for each ebook. Let's see for each example here, I will try to calculate compute the prediction, computing the hang loss, updating the gradient, and updating the weight and bias. Then for the second example, and for the until finishing the whole data set, I will update the weight and bias after each example. Now this will try to this for the first ebook, and I will try to run this several ebooks until getting, let's say, the best result. So you can see this is, if you run this, it's let's see, very easy, let's see, to follow and also to debug it. So feel free to use this and debug it, and also use it in your examples. And yeah, as you can see, I have prepared these documents and it took a lot of time. So I have already covered this concept, let's see, of support vector machine in a super easy way. And yeah, if you like this video, please subscribe into my channel and like the video. And if you have, of course, any question, just drop it down below. Thanks for watching and see you next time.